All right, guys, so we're going to do a quick video on waves. So what we've discovered over time as scientists is that electrons tend to operate like waves. So like how energy is carried through waves. We're going to talk a little bit about that. So these notes are in your OneNote, okay? And if you will follow along and fill them in, that would be fantastic. I am going to be skipping some of the notes because it's not super important. It's not stuff that we're, at least this semester, we're not going to focus on just because of everything we're going through. So you should have already had a wave and everything labeled on it. So we talked about the wave and the different parts of it. You should already have that in your notes. So I'm going to kind of go a little bit fast if I do that part, but we did talk about the crest. So the crest would be like the top of the wave. We talked about the trough being down here, that low point. The origin would be this line right here, kind of running through the center. And then I'm down here at D already. So A represents the height from origin to crest. Okay, origin to crest would be like from here to here, origin to crest. All right, we did that. Or from crest to trough. Okay, so that would be like right here. And we said that that was called amplitude. This is a refresher, really quick. Okay, and then we talked about the shortest distance between equivalent points on a continuous wave, or the way I wrote it was crest to crest, okay, or trough to trough, all right, and that is called your wavelength, okay, wavelength. That's wave. All right. So the next thing we want to talk about is frequency. Frequency. Oh, I'm sorry. Let me just go back here. This is the symbol for wavelength. Okay, so it kind of looks like this upside down Y. All right, kind of like this. Some people says it looks like the. I've heard everything: Mickey Mouse broomstick, wishbone. It's called a lot of stuff. Okay, so it's just basically an upside down Y though. It's the Greek letter lambda. Okay. And then the next thing we want to talk about is frequency. So these are all parts of the wave or attributes of it. Okay. So frequency, I'm down at number 2, is the number of waves that pass a given point per second. Okay. And this V is actually kind of like a V with a little end on it. Okay. So it's got like a little tail on it. It's also a Greek letter. Okay. It's measured in hertz. Okay, and I'm going to show you what I mean by frequency. All right, let's say that we had a wave, okay? And let's just say it was on a graph. So let's just say this graph was being measured in time. So here's the x-axis. Let's just say this is 1 second. Let's just say every, 2 seconds, 3, 4, 5, 6, okay? And you don't have to write this just yet. I want you to understand what frequency is first. So the number of waves that pass a given point per second. So I could have a wave that went like this, okay? All right. And you can see the frequency, how many waves would pass every second. I could also have a wave that would go like this. Okay, the frequency of the second line or the blue line is higher. You got more waves squished into a smaller space, okay? Then I could even have one that maybe goes like this. All right, so you can see that green line has a lot of waves in between this small space, okay? So when I'm looking at maybe just from here to here, you can see how many different waves there are by the colors, okay? So we would say that this green one has this green wave would have a high frequency, And this pink one, in comparison, will have a low frequency. Okay. All right. So the next thing I want to talk about is this B right here. Okay. And I want you to look at what we talked about earlier, which was wavelength. Okay. And compare it to frequency. All right. The notes here said that they are inversely related, which basically means if one goes up, the other one goes down. So let's talk about wavelength again. We said from crest to crest or from trough to trough. All right. So if let's just use purple here. Okay. If I look at from crest to crest on this pink line, it would go from here to here. All right. So I got one wavelength right there, and the frequency is pretty low. But as I increase in frequency, like this blue one, now my wavelength is way shorter, okay? From here to here, all right? Wavelength is way shorter. And then when I get to this super high frequency, now look how short that wavelength is. Boop, just this little line right here. These are all wavelengths, but they're super short in comparison to those. So the higher your frequency, the lower your wavelength, okay? Or you can say it backwards, however you want to say it. So I'm just going to make a note, for example. We can say wavelength. I'm going to use the symbols. So this is wavelength, okay? Wavelength goes up, then frequency goes down, okay? Or the other way around, okay? I could also say if frequency goes up, then wavelength goes down. All right, so typically we would do some calculations, but we are going to skip that, okay? If I asked you right now, which of these you think has, if you looked at these three, okay, let's just say, let's look at these three again, this green one, this blue one, and this pink one. And let me label them with letters just in case. I haven't really had to ask this year, but just in case someone is colorblind, okay? Here's A, wavelength B, and wave C. If you had to guess which one of these, if I said, ooh, there's energy, all of these waves carry energy, okay? Which one of these lines, A, B, or C, or the pink, blue, or green, which one do you think would have the highest energy? Okay. Think about, just look at those lines. Look at these squiggly lines, okay? And if you had to guess which one had a higher energy, what would you guess? If you guessed C, you are correct, okay? Look at that line. That line is intense, super squiggly. That has a lot more energy, okay? So in addition to that, we also can measure energy when we're talking about waves. So we can measure wavelength, we can measure frequency, and we can measure energy. Can you tell me what the relationship is between energy and frequency and wavelength, okay? And for energy, we're just going to use the letter E. So this is energy. All right. So what would you say here? Would it be up or down? If wavelength increases, frequency decreases, what do you think energy would do? Okay. Is it the same as frequency or is it the same as wavelength? Okay. So it looks like up here, if we go back and look, the energy of that green one is high, and so was the frequency. So I'm going to say that energy is the same as frequency. So let me write that again, and I'm going to close out this video, okay? Mainly because the bell's about to ring. But if I were to write this, okay, wavelength, let me just erase a little bit of this right now. Okay, make some room, and we'll get ready to end this video. All right. If we're talking about the relationship between wavelength and energy and frequency, wavelength, frequency, and energy. All right. All right. do it two different ways. If wavelength increases, so it gets longer, a long one, okay? All right. If it's long, then your frequency is low. And if your frequency is low, your energy is low. All right. If your wavelength is short, or if it decreases, the smaller your wavelength, then that means the higher your frequency and the higher your energy. Okay. We're going to stop right there for today.